Hello friends, today we solve the engineering mathematics problem of grade 2024 electronics and communication paper. Okay, so this is the question number 1. It is saying that a general form of complementary function of differential equation given as yt equal to at plus b raised to power minus 2t, where a and b are real constant determined by initial conditions. So we need to find the differential equation. Okay, so solution is given at plus b raised to power minus 2t. So this type for this we need to make auxiliary equation. We need to see which will have this type of solution. So this type of solution comes only when the roots are real and repeated. So for this one, first case, we have the auxiliary equation m square plus 4m plus 4 equal to 0. So which on factorizing this give us minus 2 and 2. So this will be c1t plus c2 e raised to power minus 2t. Okay, so which is of same form. So one is correct. For second, the roots are minus 2j plus 2j. So CF will be raised to power minus 0t, C1 cos 2t, C2 sin 2t. So this will not be there. Here the for third case roots are minus 2 minus 1. So solution will C1 is raised to power minus 2t, C2 is raised to power minus 1t. For fourth case, the solutions are m is equal to minus 3 and minus 2. So again, so only A is correct. Second question is in vector calculus or electrostatic, like A and G unit vector A and Y, and A with a positive constant. Then it is saying that which of the following statement true for vector field A and F1 and F2. So both are electrostatic, or only one is electrostatic. So we know that a vector field F is a valid electrostatic field if and only if its curl is 0. Okay, because electrostatic field means conservative field. So first vector is AY I plus AX j cap, second is AY j cap, AY I cap minus AX j cap. So only plus minus difference is there. So when we find its curl, we see that it's coming out to be 0 I cap, 0 j cap, 0 k cap. So this is electrostatic field F1, whereas for F2 we find it it's 0 I cap, 0 j cap, minus 2 ak cap. So this is not equal to 0 vector, so F2 is not an electrostatic field. So we just need to find the curl of both of them. So only F1 is electrostatic. Third question, here it is again on vector calculus. So here this equation is given. V with arbitrary volume, rho and u are like density and velocity, and d rho upon dt is continuous. So v arbitrary closed space and unit outward vector. So we need to apply we need to take d rho by dt plus rho dot into these four forms. So first of all, we just write it like this. We take this part minus, then we apply volume integral on both sides. So this gives us option number C as it is. Now we when apply this volume integral, we can apply Gauss divergence theorem. So this will be converted to closed surface integral, and this can be written as like this, because Gauss divergence theorem is del dot f dv can be written as f dot n ds or ds part. Okay, so volume integral can be converted to closed surface integral. Minus sign will remain as it is. So this part is A. So A is correct, C is correct, B and D are incorrect because there is no minus sign. Okay, so this is again very easy. Stokes theorem is like this. To convert closed line to surface integral, we use Stokes theorem, but it is not used here. Fourth question is on linear algebra. It is saying that let R and R cube denote the set of real number and three-dimensional vector space. Then the value of alpha 4 is the set of vectors. This do not form a basis of R cube. So set of vectors form a basis, then the determinant must not be 0 because they must be linearly independent. So if they do not form a basis, then they must be linearly dependent. So easiest way is to make the determinant not equal to 0. So 2 minus 3 alpha first vector, second vector, third vector, and we equate to not equal to 0. Okay, so when we make determinant not equal to 0, so this part is like expanding across first row. This is 2 and this is minus 7 plus 15 and minus 3, and solving this and equating not equal to 0, we finally get A should not be equal to 5. So for A not equal to alpha not equal to 5, these three will be, they will not form a basis. The value of alpha or set of vector do not form a basis in R cube. So for alpha not equal to 5, they will not form a basis. Okay, This is the so in this question, like for alpha equal to 5, the determinant will be 0. Okay, so answer will be a equal to 5. So there is some confusion here. For a equal to 5, the determinant of the vector will be 0, and therefore they will not form a basis. Okay, so a equal to 5 is the correct answer. Then this is complex integration question. So let z be the complex variable. So if z is sin pi z upon z square z minus 2, and c is a circle of complex plane with mod z equal to 3, then closed integral of z is. So here we can see that first we need to write this circle mod z equal to 3, and we see both the poles are inside this unit circle, so we need to find residue at both of them. We take the direction as anti-clockwise because nothing is given, and so the residue at z equal to 0 and z equal to 2. So first we find residue of z at z equal to 2. So this is basically limit z tending to 0, 1 upon 2 minus 1, because it is second order, so 2 minus 2 second order pole, so 2 minus 1 factorial d by dz of this whole thing, z square sin pi z upon z square z minus 2. So z square become cancel, and we apply u by v, so u dash v minus u v dash upon v square. This we differentiate, and then we put z equal to 0. So cos 0 is 1, sin 0 is 0, so this thing simplified to minus pi by 2. Now for at z equal to 2, the residue is it's a simple pole, so limit z tending to 0, z minus 2 sin pi z upon z square. So this is sin 2 pi upon 4, so 2 pi is 4, 2 pi is 0, sin 2 pi, 0 by 4, 0. So therefore closed integral left till z plus 2 pi r times sum of all residues. So this is 2 pi I minus pi by 2 plus second residue, so 2 cancels, so minus pi square j. So correct answer is D. Sixth question is like f1, f2, f3 be functions of xy. Suppose that for every gain pair of point in B, line integral this thing evaluates to same value along any path, then which start at A and B. So the basic line integral depend only on end point and not on the path chosen. So then which of the following is true? So f dot dr is independent of C and it only depends on end point. So this simply f vector f, which can be written as f I k f2 j k f3 k k, is path independent, so it's conservative vector field. Okay, so it does not depend which path you take, it only depend on end point. And conservative vector field means its curl will be 0. Curl will be 0 means the determinant will be 0, so these things will be 0. So option D is correct. And another property of conservative vector field is that work done in moving particle along closed path is 0. So for every closed path this integral will be 0, so this is also true. And another property of this any field whose curl is 0 is that a conservative vector field like electrostatic field or gravitational field can be always written a gradient of some scalar function. For example, electric field is minus L times potential, electric potential. Okay, so f can be written as some gradient of some function, which is like del f upon x, del f upon dx I k. This is the definition of gradient, and our f vector is also like this. So equating both, we get f is equal to del f upon del x, f2 equal to del f upon del y, and f3 equal to del f upon del z, which is exactly option B. Option C is wrong because it is saying the divergence will be 0. So this is not correct, because f can, and it also means the Laplacian scalar Laplacian 0, because f can be written as del f, which is like del dot del f del square. So all Laplacian 0 and divergence 0 cannot be, these two cannot be deduced from the given information. So C is wrong. A, C, D are correct. Last question is on linear algebra eigenvectors. Is saying to consider the matrix this where k is a positive real number. Which of the following vectors are eigenvector? So 4 eigenvector given, matrix is given, we need to find out which one is correct. So for that, first we will find the eigenvalues. So we will use this a minus lambda, I think, we'll solve this. A minus lambda equal to 0, A this matrix. So on getting this get 1 minus lambda square minus 2k equal to 0. So 1 minus lambda square is equal to 2k. So 1 minus lambda is equal to plus minus root 2k. So 1 minus root 2k is lambda and 1 plus root 2k is lambda 2. So these are the two eigenvalues. Now for each eigenvalue we'll find the eigenvector. Okay. So for eigenvalue 1 minus this first eigenvalue 1 minus root 2k, we will use ax equal to lambda x, the eigenvector equation. So a minus lambda ax equal to 0. So this is a minus lambda, I put this value 1 minus root 2 can this thing identity matrix times x1 x2 let with eigenvector equal to 0. So 1 minus of 1 minus root 2k, and then this is 1 minus of 1 minus root 2k. So this is minus root 2k plus root 2k 2k x1 x2 equal to 0. So this is like minus root 2k x1 plus k x2 equal to 0. So then we can basically do it. K x2 is equal to root 2 under root 2k x1. So x1 equal to k under root 2 under root k. Okay, x1 can be written as, and this part will go to denominator, so it will be, so basically x1 is under root k by 2 x2, or from here also you can do x2 equal to root 2k by k. So x2 is equal to root 2 k x1. So if x1 is 1, then x2 is under root 2 by k. So x1 is 1, then x2 is under root 2 by k. Okay. So this is your option number B. Similarly, when we take the another eigenvalue, which is your 1 plus root 2k, the second one, then for that we will get 1 minus under root 2. So these two are the correct option. It is a tricky question. So these were the all 7 problems. Thank you.